One of the most important theorems in geometry and algebra is the one that is called the Pythagorean Theorem. Why is it so important? It is because when you want to measure a triangle that has the characteristic that it is a right triangle, then the Pythagorean Theorem is of a lot of help. Now, basically, what is the Pythagorean Theorem talking about? Okay, the theorem states the following. If a triangle is a right triangle, then the sum of the squares of the lengths of these legs A and B will equal the square of the length of the hypotenuse. Okay? Now we're going to understand as hypotenuse always the longest side of the right triangle. In this case, the side that is opposite to the 90-degree angle. And we're going to identify as legs the other two sides of the triangle, A and B. By convenience, we usually identify A as the shorter side and B the intermediate side between A and C. Now, mathematically speaking, the Pythagorean theorem can be written in the following way. A squared plus B squared equals C squared. Now, as I was telling you, this is one of the most famous theorems in geometry and in algebra. And if I am not wrong, it has approximately 476 demonstrations. Now, we're going to just concentrate on the first one, which was the one that is assumed the Pythagorean students of Pythagoras deducted a long time ago in ancient Greece. What are they talking about when they refer to the process of the squares of the lengths? Let's imagine that with this side of A, we create a square, okay? Whose side also is A, and then by area, we have A squared. Then I do the same with B, okay? I make a problem elongation of side B, okay, and then I find out that I have another square. This is B, and B times B becomes B squared, the area of this one, okay? And finally, we apply, and the theorem says that the addition of these two squares will be equal to the area that is going to be created in here on a square that will have the side measuring letter C. So, if we go like this, and if you see I have a problem with the board in here, then C times C becomes C squared. So, the theorem is telling me that the addition of this area, okay, which is a square, the addition of this one, which is called B squared, the addition of these two will be equal to the area that is found out in the hypotenuse. Okay, and this is what is called the Pythagorean theorem for a right triangle. We will continue with some examples on how to use the Pythagorean theorem. Now we're going to solve two problems involving the use of the Pythagorean theorem. If you see, use the Pythagorean theorem to find the missing side of the given right triangle. Now the condition is that the two triangles must be right, okay, so that we can apply the Pythagorean theorem. So let's remember, by convenience, we always identify the longest side of the triangle as letter C, and the other ones are going to be the two legs. So in this case, the shorter leg will be identified as A, and the intermediate leg will be called B. So if we analyze this problem, what we have really is, okay, let's apply the Pythagorean theorem. A squared plus B squared equals C squared. And if we replace the information that is given to us, what we have is 12 to the second power plus 16 to the second power and C, which is my unknown value. So once we start solving, this becomes 144 This becomes 256, and c squared equal to c squared. The addition of these two, it gives me 400 equal to c squared. Now, in here, if you remember, what we have is a quadratic equation that can be solved simply by applying the square root. And in this case, we're going to break a little rule that we learned from algebra. Because when I apply the square root, I have to consider two answers, one that is positive and one that is negative. But in this case, a negative answer for the length of a side will be illogical. So we're only going to consider the positive value. Therefore, in this case, this problem is telling me that c will be equal to the square root of 400, which is equal to 20. Therefore, this is the missing side of the first triangle. Okay? Now, let's go with the second one. The second one is a very similar situation, but in this case, we know the value of the hypotenuse, which is 26, because it's opposite to the 90-degree angle. We know the intermediate side, which is 24, and the one that we don't know is the shorter side. So, according to our values that we're having, this is A. Here, we're going to identify this as B. And this one will be known as letter C. So, once we apply the Pythagorean theorem, we have a squared plus b squared equals c squared. So in here, we're going to have a, which we don't know the value, 24 to the second power equals to 26 to the second power. So once we have these values in here, what we discover is that we have a squared plus 576, and this is equal to 676. So if you start solving this equation, you discover that a squared is equal to 676 minus 576, and a squared is equal to 100. Again, as we did it in the previous exercise, we apply the square root on both sides of the equation, and we only keep track of the positive answer because I don't want negative values as the measurements of triangles. Therefore, the answer to this problem will be C equals the square root of 10, A equal to the square root of 10, the square root of 100, which will be positive 10. There we have the answer to the two exercises that we have in here. One in which we were finding the hypotenuse, one in which we were finding one of the legs. If we want to find the value of B, then we will know A and C, and what we do is we leave B alone, and exactly the same procedure as this one. So I hope that you understood the application of the Pythagorean theorem. The converse of the Pythagorean theorem tells me that if a triangle has sides A, B, and C, such that they fall into this equation and the answer is a true statement, then the triangle is considered a right triangle. So in other words, what they're telling me is that if I have sides A and B and I add their squares and then I square side C and these two results are exactly the same, what I have is the sides of a right triangle. So what we're going to do right now is two examples in which we're going to use the converse of the Pythagorean theorem to prove if the sides that are given belong to a right triangle. So, let's analyze the first one. The first one says that I have sides 27 yards. I have another one that measures 3 square root of 115 yards. And finally, I have another one that is 33 yards. So I have the three sides of a triangle. Okay? Now, what we have in here is three sides, and I need to prove if these sides, they follow this rule, that is the Pythagorean theorem. Obviously, I need to know which of these sides is the longest one, because I have one that is expressed in simplest radical form. So if you click on your calculator, you will discover that this one is approximately 32.17 yards. Therefore, we can clearly see, okay, that what I have in here is side A, here I have side B, and therefore this one, which is the longest one, will be considered side C. Now, to prove the converse, we're going to do this. We will take A squared, and we're going to add it to B squared. So in here, what we're going to have is 27 to the second power plus 3 square root of 115 to the second power. And then we add this expression. The result of this is 729 plus 1035, which is the result of squaring this expression. And finally, the answer is 1764, which is the addition of these two. What are we going to do now? Take the third side, which is C squared, and make it C squared. Okay, so we're going to take 33, and square that value. Okay, then the squaring of this value will give me as an answer 1089. And if you see in here, it is very clear that these two elements in here are not equal. Therefore, we can have as a conclusion that since they are not equal, then the three sides that were given they do not belong to a right triangle. Very easy to prove. But we're using the converse to prove if the sides of a triangle are parts of the sides of a right triangle. Okay? So it is very easy. We identify the two shorter sides, we identify the hypotenuse, and then we write the expression and we equal the two results. If they are not the same, then the sides do not belong to a right triangle. Okay, now let's analyze a second problem. A second problem in which the sides of a triangle are going to be part of it. So what we're going to prove is that the answers are exactly the same on both sides. So let's analyze example number 2. Example number 2 will be the following way. We have the sides, in this case, of a triangle that are 1 meter. The second side will be 4/3 of a meter. And the third side will be 5/3 of a meter. Obviously, since we will be working with fractions, the idea is that we have everything expressed as a fraction. Okay? So what I'm going to do is take a look at the denominators that I have in my expressions in here. And since my denominator is 3, then I will write an expression for 1 meter that has a denominator 3. And to make this one, what I need in here is another 3 on the top. So here we have the three sides of the triangle. 3/3, 4/3, and 5/3. So obviously this will become A, this will become B, and finally this one will become C. So let's proceed to use the converse and prove if these triangles are correct. If the sides of these triangles are correct. So we take 3/3 and we raise it to the second power. We add it to 4/3 to the second power. And let's remember, the power in a quotient affects both numerator and denominator. So this becomes 9/9 plus 16/9. And since they have the same denominator, then we are going to have 9 and the addition of 9 and 16, which is equal to 25. Now let's take the second part, which is squaring letter C. Letter C will become 5/3 to the second power. And once we solve this expression, we have 25/9. Obviously, we are coincident that the two sides of the expression are exactly the same. So in this case, since they are equal, then the conclusion that we have is that the sides belong to a right triangle. And there we have it. This is how we use the converse of the Pythagorean Theorem. The converse is used when three sides are given and we want to prove if those sides belong to a right triangle. So we just simply add the two shorter sides. When we find an expression, we square the longest side, and if these two results are exactly the same, then we have a right triangle.